Welcome to our panel building workshop, where we explain the art of panel building.
We're gonna have a look at the new products and what kind of benefits they have to the panel builder. I've collected some of those new with the old ones and put them on a DIN rail. We're gonna have a look at the power supplies. So I've got the very old one, 10 years old I think, and then we had a newer one 2 years ago, and now we have this brand new one. What the differences are. So in the old times we had the power, the 230 volts AC at the top, 24 volt at the bottom. It gives you a problem coming from your MCBs to feeding them, so you need to go down top there. So we changed the direction in the new ones. So now I've got the 24 volts at the top and the power, the AC at the bottom. And this one we kept the principle, but we make it super power efficient, so it could be much smaller. And if you look in the instruction manual, you'll find there that on top you have for these two 60 millimeters free space needed for ventilation, and this one only 25 millimeters.
That is what I want to show you.
Yeah.
Normally you had all those different fields. And if you now look to the cabinet that I designed here, they all have the same fields. So if I enlarge it, I already placed
140 millimeters.
That's 140 millimeters each field.
Why is it so important that there is 140 millimeters field? And that we have 2.5 centimeters on top and 2.5 at the bottom?
If you start, for example, on the galvanic plate, let's start at the top. Cable duct 45
always.
millimeters.
Yeah.
Yeah? At least what you need. If I then go to the second, is also 45, third 45, and at the bottom we place the 65 at least. That is what we need. Then we have that protective earth rail. It's also what we need if you want to do it properly, and some free space to make the connection.
Otherwise
so
you can't get in with your hands.
So if you make the calculation then you come about that 140 millimeters. So I've placed here the first one that you saw here, the old one.
Yeah, but you need 60 millimeters on top.
That's not 60 millimeters.
No.
If this is 70, then this is not 60.
No.
The bigger one, but smaller one, also doesn't fit.
Yeah.
So I'm going to place now the new one, the last one.
Yeah.
And if I place it here, then you see this is, I think, almost
25 millimeters.
to your 25 millimeters. We can measure it. So I'm laying it here. I'm doing some measurements to the cable duct. And guess what?
25 millimeters, great. That's what we need.
Yeah.
And you can put it everywhere. So
I can pick it up and put it on my other field if I want to.
And all the products have the same height, so and all probably need that 2.5 centimeters on top for ventilation. Good, and everything fits in every field. Great, nice.
So better airflow,
Better,
easier placement,
shorter wiring.
shorter wire. So it's quite universal. And even if you take the other cabinets, then maybe at the bottom you can win 1 centimeter or 2 centimeters, but your fields in this case, with 140, is an ideal position.
A very logical layout. So next to the power supplies we have the relay sockets for the GT-RV, these small ones. So you prepared already something on screen?
I placed a few of them.
5 of them together?
Yeah, that are the old ones.
Yeah,
and now I'm going to pick out the new one. And I'm going to place it next to the old one. And you're surprised, eh?
Not much difference
No.
in size.
In total maybe 10 millimeters difference. So
Yeah, in height.
Yeah.
But you haven't seen a difference in depth. So this is the old one. And I've got here a new one. Now you compare. This is
almost the
height of relay. Yeah. So you get a better airflow through your cabinet because there's less obstruction. Yeah. Should we go any smaller than this? I don't think so. Eh?
I don't think it's possible, René, because you always have the wire that needs to be inside.
Yeah.
And
I mean in height. Eh?
Yeah.
And there's also electronics in this that regulates the voltage to the coil here. So I don't think we can physically go any smaller, because how you need to have mass to dissipate this heat and then get rid of it into the cabinet. That makes them more reliable if you keep them a bit bigger, so we can have a better inside temperature.
You know that the temperature does in the cabinet, it's getting really hot.
10 degrees increase in heat makes the lifetime in half. Yeah.
So your machine is not running for 10 years, but for 5 years. And 5 years still long, but still you want to have it for 10 years.
Yeah. So we have also now these bridges to connect relay sockets to each other. Those
small things.
Yeah. So you come with one connection point on your relay socket, and then you feed multiple of them. We got them in different lengths.
So you have one wire coming in. You can feed
on this one,
relays.
and then you put in the bridge like this. Okay. And then you need to calculate the amount of current you're going to feed through this. Can the bridge do it? And can this wire coming to here can also do that. Okay. And if it's too much, you need to have to have more connections with more bridges.
Use simply more bridges.
Yep.
Depends on the amount of current that you need.
Yeah. Yeah. No twinning anymore. I didn't like twinning at all. It's past.
No, now it's single wire.
Yeah. The next in line is the timer and control and measurement lineup. So I've got here a phase monitor device, and funny enough I've got here timer relays. That's where it all started off with Omron. Mr. Tataichi developed a timer relay for X-ray machines way back 70 years ago. This is his first development.
Do you remember the old times?
Yeah,
you have to set the
with
timers.
the older device. Yeah, I needed to have my glasses on, especially with my age. And I don't really need to do that with these ones because I can really see what the setting is. You've got this nice bright arrow, this dot, and you can really see the printing on the device, so I know exactly where my setting is, how much.
And what about the placement? The placement on the panel. When I look at the size, for this for example, we normally would place these things nearby some relays or some terminals, place them far away. But you can also place them now in the field size or where the power supply is located. They can withstand a lot of noise.
Yeah, the power supply is a lot of noise. It's a switching power supply. And by nature, switching power supplies generate a lot of electrical and magnetic fields. Yeah.
So there are some extra advantages. One is the view, as you already said.
Yeah.
The brightness is much clearer. There is push-in technology.
As with all the other products.
Yeah. The size, less heat, less power consumption, and easy placement.
And they are totally in line with these ones, same height. So your airflow is also not restricted.
Makes our life easier.
Next, the solid state relay. So we have an old one and a new one. And the difference is mainly, I think, is here the connection technology for the control. So here you have here control points, which is here screw. And over here we have push-in technology. And you have double pushing technology, double points. So it's easy if you have 3 of them, so you can jump from one to the other to the other.
Yeah,
so
there are some wiring bridges what you can use.
Yeah.
Yeah. Solid state is something else, huh?
Yeah, it's not a relay. It is a big transistor actually, and it generates quite a lot of heat. That's why you have this whole massive block of aluminium below it to get rid of the heat.
I mean, if you look at the solid state relay and you're going to place a solid state relay here, for example, you can see it fits in every field that you can imagine.
Yeah.
It is small, but there's something else, because you know what is.
You need to read these. It says in the instruction manual, hey, listen, there should be 60 millimeters above for ventilation. And in this field, they're not going to make it.
So a lot of people make mistakes with solid state relays. They don't give enough space for the heat dissipation.
That is the responsibility of the one who builds this whole cabinet, that thermally it is working properly. It is in the standard, the IEC 61439 you have there, describes this, that you really need to make sure your whole setup, the thing you composed, the thing you built, is built according to the manufacturer instructions, and that you not go over any limits.
If you read this manual and you read it a little bit, then most of the times you can find that you need to calculate.
Yeah.
The engineer decides what's to place where, and he needs to calculate about the heat. He needs to calculate about all kinds of things.
Yeah. And as a component manufacturer, Omron only gives you the installation instructions, and you should work with these.
Yeah, this is just a guideline, and in this book also in the IEC is written that you should mount it as the manufacturer tells you to.
And if you do it differently,
you have to explain why.
Yeah. And you need to put that in your technical file for your CE mark. So in the last set here we have the new relay sockets, and we have a small one for two connections and the bigger ones for 4 connections. A nice thing of those is that you have also double connections, so you don't need to do twinning.
It's the push-in plus, so yeah, it's very soft. And next to that we also have all these types of short bars that you can use for all these type of sockets.
So you have only one wire going to your power or your grounding, and the rest of the power you distribute then by the short bars to the rest of the relays.
Different color, different type, different lengths, all kinds of things are possible. However, not only that, but you have a universal socket. We always had that, but this is easy replacement. Suppose you want to have another functionality like a timer, a mechanical timer. Finished.
Yeah, finished. But you have it this way, and I need my glasses. This way, and I can read here, but it was there like this, but I want to see it like that. But I can still read here the contact numbers. So A1, A2. If I look at here, I've got still A1, A2. Yeah. So if people ask why did they put in double printing, one side upside down, it depends on how you connect those, how you place it. So if I take just a simple relay, for instance, this one, you can mount it here in your panel, and depending on where your control is of that relay, it comes from here, like from the field, from the sensor, and then your output goes there, or other way around. Your input for your relay is in the PLC, so the PLC is controlling the relay and the outputs go to the field. That makes sure that your wire is as short as possible. You don't need to get from your PLC all the way around to the console.
So you don't cross the wires anymore, so you have less wires in your cable ducts?
Yeah. One thing is a pity. The printing on the relay itself is upside down.
You cannot have it all.
No, for sure. I hope you enjoyed our little explanation about the benefits of our products. If you have some questions left, just create a ticket on myomro.com or just simply drop us a mail.
See you next time.